TokenCanary Dashboard Technical Analysis. Welcome back to TokenCanary. In this video, we're going to take a deep dive into the technical architecture of our security dashboard. We'll explore how each component works together to detect potential threats in Uniswap V2 tokens and provide you with actionable security insights. Whether you're new to DeFi or an experienced investor, understanding these analytical tools will significantly enhance your ability to identify and avoid fraudulent tokens before they impact your portfolio. Dashboard Architecture Overview. Let's examine the architecture of the TokenCanary dashboard interface. The platform is structured into three distinct analytical visualizations: Honeypot Detection Framework, Liquidity Lock Verification System, Smart Contract Security Assessment. Each visualization represents a critical security layer that provides complementary insights into token integrity. Let's dissect each component to understand their analytical purpose and data interpretation methodology. Honeypot Detection Framework. In this visualization, each data point represents a newly deployed token. The vertical axis quantifies the initial liquidity provision, while the horizontal axis tracks temporal deployment. The color coding system categorizes tokens into three distinct security classifications. Potentially legitimate. These tokens lack immediate fraud indicators but remain unverified due to absent liquidity locking mechanisms. Without committed liquidity in a recognized locking protocol, the contract deployer retains the capability to execute a liquidity withdrawal event, commonly termed a rug pull. Functionally compromised. This classification identifies tokens where liquidity appears locked, yet transaction testing reveals operational failures. These failures manifest through prohibitive transaction fees or contract-level mechanisms that obstruct standard trading operations. Such tokens exhibit clear indicators of malicious design intent. Confirmed honeypots. This designation identifies fundamentally fraudulent tokens by design. They either operate with negligible liquidity or implement overt scam mechanisms detectable without requiring sophisticated analytical techniques. Note the significant correlation between liquidity volume and potential investor risk. Even substantial liquidity pools present exploitation vectors if not properly secured through immutable locking mechanisms. High liquidity can function as bait to attract unsuspecting market participants. Liquidity Lock Verification System. This visualization differs critically from the Honeypot Detection Framework in that it exclusively displays tokens that have initiated liquidity locking procedures. The horizontal axis quantifies the actual secured liquidity following the locking transaction. A crucial pattern to observe is the prevalence of tokens displaying minimal vertical axis variation, indicating contract deployers who executed liquidity locking procedures but extracted the majority of funds prior to commitment. This technique creates a false impression of security. Additionally, note the deployment patterns showing multiple tokens with identical liquidity parameters launched within precise timeframes. This synchronization strongly indicates systematic deployment of variant contracts from a single malicious entity, often with minimal modifications to the underlying code. Smart Contract Security Assessment. The uppermost visualization represents our most sophisticated analysis tier. This displays tokens that have passed initial security screening by demonstrating locked liquidity and no obvious fraudulent characteristics. These contracts undergo evaluation by our specialized machine learning model trained on an extensive corpus of smart contracts to identify subtle exploitation vectors. Our AI-powered security protocol examines numerous technical parameters including fee structure implementation and transparency, concealed taxation variables, privileged address designations, anomalous fee calculation methodologies, cell restriction mechanisms, block number manipulation techniques, router interaction patterns, non-standard price impact algorithms, transfer limitation frameworks. The system also evaluates positive security indicators including standard implementation adherence, code transparency and readability, implementation of recognized security best practices, security assessment methodology. Our comprehensive token evaluation employs a three-phase security verification process. Initial honeypot detection to identify obvious exploitation vectors. Liquidity commitment verification to establish baseline security commitment. Advanced AI-powered contract analysis to detect sophisticated exploitation mechanisms. This multi-layered approach provides a comprehensive assessment of token security across the DeFi ecosystem.